Okay, so yesterday we talked about parallel lines that were cut by a transversal and all the different types of angle relationships that are created there and how we can use them. So for example, corresponding angles are congruent when you have parallel lines cut by a transversal. Alternate exterior, alternate interior, congruent when you have parallel lines cut by a transversal. Same side interior or consecutive interior are supplementary when you have parallel lines that are cut by a transversal. So today we're going to talk about, hey, we just have these two lines and they may or may not be parallel and they're cut by a transversal. How can we prove they're parallel? So we're going to use kind of the backwards version, so the converse. Okay, so we're going to say this value here, what value of x would make m and n parallel lines in this example? Well, these would be, if the m and n are parallel, then these are corresponding angles, which means they need to be congruent to make m and n parallel. So we're going to set them equal because angles that are congruent are equal. And so 3x plus 5 then needs to be equal to 65. So then I can solve that and I get 3x equals 60. Divide by 3, I get x is 20. So the value of x that makes m and n parallel, because those would be corresponding angles, is 20. Okay? And I'm not hugely worried about the word converse here. I just want you to know that they're corresponding angles based on their location. Okay, and like I said, this also goes for alternate interior and alternate exterior angles. So if angles 4 and 5 in this picture are congruent, then J and K are parallel. If angles 1 and 8 on these alternate exterior angles are congruent, then J and K are parallel. Now I have this labeled, same side interior is the same as consecutive interior. They mean the same thing. Okay, they're interchangeable, so I'll use both. And they are not congruent, they are supplementary. And so this is very, very important. Supplementary, not congruent. So same side interior and consecutive interior are supplementary. So they add up to 180 degrees. They sum to 180. So we're going to decide if we know these angles are the same, these angles that are marked, then is that enough information to say, oh yeah, these lines are parallel, m and n are parallel? And if so, what kind of angles are they? So the theorem that we would use. So on this first diagram, we have these angles here, and they are in the same place in relation to the lines and the transversal. So m is parallel to n because they are corresponding angles. And you can say corresponding angles converse, but I'm just going to say corresponding angles because that's the important part there, that word corresponding. Okay, we have B here, and I have these two angles that are marked here with the transversal R and these lines M and N. We don't have enough information here. These are vertical angles, which is great, and we know they're congruent, but we have zero information about the intersection of R and N. Zero, zilch, nada, not enough information. Okay, now we're looking at this last diagram, and there's nothing about line S. We can just kind of ignore it in this picture. And then we have this angle here that's on one side of our transversal R, and this other one that's on the alternate side, and they're exterior. So those are alternate exterior angles. And since they are alternate exterior angles and they're congruent, then I can say that M is parallel to N. Okay, on this one, we are going to find the value of X to make these two angles, which are alternate interior angles. Alternate interior angles. And so again, they're alternating sides of this transversal line here, and they're interior to those parallel lines. And so we know they should be congruent. So we get 14 plus 3x equals 5x minus 66. So then we can solve this and subtract and get 2x minus 66 equals 14. And then 2x equals 80. So we know that x is equal to 40. Okay, and that is the the value for x that would make L and M parallel lines because they need to be congruent angles. Okay, again, we're going to be looking at the relationship of the angles here. So we have this angle and this angle. Okay, those are same side. They're on the same side of the transversal and they're interior to the two lines. So they are same side interior or consecutive interior angles, which means they are supplementary. Sorry, they're supplementary. I'm just writing that because they're the one type that we're going to talk about that are not congruent. So what that means is, for these to be parallel lines, for A and B to be parallel, I need 7x minus 8 plus 62 to be equal to 180 degrees, because that is the value that's going to force those lines to be parallel. Okay, because they are supplementary. So then I can do 7x plus 54 equals 180. So 7x is equal to 126. So x is equal to 18. And that is the value that is going to make those same side interior angles supplementary, which then will force A and B to be parallel lines. Okay, this one, we're looking at these two angles here. Same thing. Oh, I see they're on alternating sides of the transversal. So this is our transversal line. And to make L and M, apparently I can't read letters today, parallel, they need to be congruent because they're alternate exterior angles, because they're on alternating sides of the transversal, so opposite sides, and they're exterior to the parallel lines. So the equation would be 3x minus 33 and 2x plus 26. Oops, 26. You can solve that if you would like, but we're not going to solve that today, just in the respect for time to keep going. But again, alternate exterior angles need to be congruent to make L and M parallel lines. Okay, our last property we're going to talk about today is the transitive property of parallel lines. And so if you remember, the transitive property is like if two things are equal to the same thing, then you can set them equal to each other. So it's almost like that middle piece cancels out. Same thing goes for parallel lines. If P and Q are parallel and Q and R are parallel, then that makes P and R also parallel. So we're like using the fact that they're both parallel to line Q to say that they're parallel to each other. All right, so in this diagram, it says P and Q are parallel and Q and R are parallel. Oh, look at that. Now I also know that P is parallel to R because of the transitive property of parallel lines. So then I can look at this and say, oh, hey, look at these two angles here. These are on a set of parallel lines. So this is a type of angle that we actually haven't talked about, but these are called same side exterior angles or consecutive exterior angles. And they are just like same side interior or consecutive interior, and they are supplementary. Okay, and so since we know that P and R are parallel, we can use the fact that they have same side exterior angles and that they're supplementary and say 115 degrees plus the measure of angle 8 is going to equal 180 degrees because that is the definition of supplementary. So the measure of angle 8 is then 65 degrees because that is supplementary. Okay, so we are going to write a proof here, and what I'm going to say about this proof is it's unlike a lot of other proofs. You'll see why in a minute here, but just stick with me here, and we're going to write a proof, and we're going to use some of these angle relationships. So the first thing we're going to do is going to get our given in there. So our given is the measure of angle 1 is equal to 115 degrees. And the measure of angle 2 is equal to 65 degrees. and that's given. And we know that we're going to be trying to prove that M and N are parallel. Okay, so the first thing I'm going to do is I'm going to write a statement because I know where I'm headed with this. And my statement is going to be 115 degrees plus 65 degrees is equal to 180 degrees. And we all know that that's true. We all know that 115 plus 65 is going to be 180. Well, and the reason we know that is because it's the mathematical properties of addition, but we're just going to write math here. Okay, and I know that's a weird reason, and I'm not going to give you a proof that I'm going to expect you to figure that out on, but for our purposes here in being able to write this proof, we're going to use the reason of math. And then we're going to take this equation that we wrote, and we're going to substitute in the measure of angle 1 for 115, and we're going to substitute in the measure of angle 2. Okay, well, I just said it twice, so our reason here is substitution. That's why we can write that equation. Okay, and then we're going to come here, and we have 4, and reason number 4 is going to be that angle 1 and angle 2 are supplementary. Okay, and then so my reason for that statement is going to be the definition of supplementary. Okay, because I know that if two things add up to 180, that they're supplementary. Two angles, I should say. So then our last statement here is going to be that M is parallel to N. So line M and N are parallel. And the reason we can say that is because they have consecutive interior angles that are supplementary, or we can use the consecutive interior angles converse. Or if you wrote same side interior, that is also very acceptable. And that's because they're supplementary. They have two interior angles on the same side of the transversal that are supplementary, and so therefore lines M and line N are parallel. Okay. Give the homework a go on Big Ideas 3.3. Let me know if you have questions, please, and we will chat next time.